Okay, so yesterday we were talking about 9.3 and we started doing notes that discussed how long this classic rock radio station was playing music, right? And we said that we suspected that it was under 50 minutes, right? They claimed to have 50, but every time we turned to the station, there's a commercial playing, so we thought it was going to be less than 50. So in our notes yesterday, we did the beginning, which was our state. So, hold on, my computer's catching up. So, the null claim was that they play 50 minutes of music per hour. We're trying to prove that they're less than 50 minutes of music per hour. And we did our checks. We did random check, our independent check, and our normal check. Remember, oh, fantastic. Remember, because we don't have a sample of 30, we had to come over here and do our graphs, right? We had to check for no outliers and make sure there wasn't a lot of skew. A little skew is okay. All right, so to finish this, we're going to do the do part and the conclude part. Okay, so this information is obviously always given to you. We should have this in our calculator. We entered all of our data in our calculators to make sure that we could do our graphs. So if I pull up my data here, if I do stat and I look into L1, all of the data has already been entered here. So all of this information that I need, I can get from one variable stat. So if I push stat, go to calculate, and I choose one variable statistics, and I run that information, I'm getting all the information that I could technically need. Okay, so as I look through here, the first thing I need is X bar. So I go to my calculator. X bar is up here. It's 47.92. So 47.92 minus mu sub 0. That's the claim. You know, the radio station claimed to play 50 minutes of music. So 50 goes in here. Over standard deviation of X. So S sub X. Let's go back to the calculator. S sub X is over here. It's about 2.81. Over the square root of n, so square root, and my sample size was, we said it was 12, so square root of 12. Okay, so let's go ahead and type this into the calculator. I'm going to slide this over so we can see it. When you're typing this in the calculator, make sure the entire numerator is in parentheses. So this would be 47.92 minus 50. There's my numerator. Divided by, now let's put our entire denominator in parentheses. 2.81 over square root of 12. And we'll close those parentheses. I get a t-score of negative 2.56. So negative 2.56 is my test statistic. Okay, if you notice, we're on the left side. So if I'm looking on the left side, they claim to play 50 minutes of music per hour. We're negative 2.56 standard deviations to the left. So I'm on the left side. There's negative 2.56. I want to find out this area. Okay, so in order to do that, that's going to be my p-value. In order to do that, I'm going to use my calculator to figure this out. Okay? All right, so follow along with me, and if you need to replay this, you can access this again. We do second and then choose distribution. It's right by the vars key. Okay, because I'm doing a t-value, I'm going to go down to option number 6, where it says TCDF. Okay, and they're going to ask for a couple things, the lower value, the upper value, the degree of freedom. Okay, so as we go through this, the lower value is how far left does this graph go? Well, this graph goes to the left forever. So I'm just going to pick something on the very far left side, like maybe negative 1,000. So negative 1,000. The upper value is where does it stop on the right side? Well, if this is all the way at negative 1,000, it technically stops right here at this value, which is negative 2.56. And then it's also going to ask us for a degree of freedom. So this degree of freedom is a little new to you guys. So df, we'll write this down, df is called a degree of freedom. It's got a very simple formula. It's your sample size minus 1. So our sample size was 12 minus 1, so now I have a sample size of 11. Go to the calculator, type in 11, paste it. Okay, this is what it'll look like in the calculator. Push enter, and then that number that pops up, this 0.013, that is your p-value. So that's 0.013. That's what we are going to use to help us conclude things on the last part of this question. Okay, so when it comes for the conclude, we'll say since our p-value which was 0.013, was less than our alpha value that we set at 0.05. We reject HO. Okay, so what I'm saying is that it is not 50, that the radio station does not play 50 minutes of music per hour. If I reject HO, that means that there is enough information, or there is enough evidence to conclude what we are trying to prove. Well, what were we trying to prove? We were trying to prove the true mean number of minutes of music played per hour at this station is below 50. So technically what we were trying to prove from the very beginning was correct. So let's kind of go up here and just kind of look at it again. Okay, so the whole concept here was the radio station claimed that they play 50 minutes of music every hour. You thought, because every time you turn to the station there's a commercial playing, you thought they were less than 50. So you thought that they were over here, they weren't 50. So your sample came in over here, which proved that you guys were right, that the null hypothesis was wrong, they don't play 50, and that you were right, they played less than 50. Now, just in case this happens, you might not always get a t-score that's negative. So let's kind of go back to our answer. Okay, you might not always get a test statistic that's negative. Excuse me. Sometimes you might get a test statistic that's positive. So if, in fact, you got a test statistic that was positive instead of a negative, so this is kind of separate from your notes, so let me erase these things so I can kind of show you the other side. So what happens if your test statistic, after you did all of this work, came out to be 1.86? Okay, so then technically, if this was 50, your test statistic, because it's positive, was on the right side. Here was 1.86. To turn that into a p-value with your calculator, let's do it again. You would hit second distribution, so second vars, it's right here. Go down and choose TCDF, which is option number 6. This time the lower side is like the left side. Well, if I'm looking over here, the left side is at 1.86. So I would type in 1.86 here. The upper side well, this thing doesn't have an upper side. It kind of keeps going on and on and on. So the upper side would just pick a big number like 1,000. And then the degree of freedom would have stayed 11. So when you paste it, that's how you would get your right side. In case your test statistic was positive, your p-value would be 0.045. So I just wanted to show you guys what happens if you get a positive test statistic versus a negative test statistic. Okay? All right. The substitute is going to pass out your homework. Please use these notes as practice on getting that homework done. And let me know if you have any questions. All right, thanks, guys.